epsilon less than 3 delta. So we given epsilon, we can find delta that less than epsilon over 3. Okay, so delta is greater than epsilon over 3. All the thing right here I'm showing you is to find the relationship between epsilon and delta. Whenever you have an epsilon, okay, you try to find a delta. Okay. So whenever you have an epsilon, you choose delta to be greater or equal to epsilon over 3, and the problem would work. And this is the work behind the scene, really. And this is how you show your calculation or show your proof if you know the limit. Right? Let me rewrite the problem up here. Calculate the limit of 3x squared y over x squared plus y squared when x, y approaches 0, 0. Okay? Now I'm going to use a definition. This is the thing that I need. All right, so first of all, you have epsilon positive. I'm going to choose delta to be epsilon over 3. Okay, got from here. Oh, greater than epsilon over 3, but I think equal is good enough. And then if x squared plus y squared square root to be less than delta, then I'm trying to show that. Then at the end, we try to show that 3x squared y over x squared plus y squared to be less than epsilon. Okay, so we start with this, and we're going to kind of go backward from what we have in here. If this is less than delta, this means that square root of x squared plus y squared to be less than epsilon over 3. Okay, so I need some room to write. I'll put it right in here. Okay, so this means what? 3 square root of x squared plus y squared less than epsilon. Multiply back 3 in both sides. Okay. And now what? 3 square root of x squared plus y squared right here. And this is greater than 3 square root of y, right? 3 square root of y to be less than 3 square root of x squared plus y squared. Still less than epsilon, right? Because square root of y squared, I mean. Because x squared is positive, right? So x squared plus y squared is going to be bigger than y squared. The 3 squared y squared is going to be bigger than or equal to if x equals to 0. Okay? So what we have is right here 3 square root of y squared, which is 3y, to be less than epsilon. Okay? Together with 1 here. 1 is greater than x squared over x squared plus y squared. It's greater than 0. This amount is always between 0 and 1. Because x squared is positive, x squared and y squared plus y squared all positive, but x squared is less than or equal to x squared plus y squared. Now positive, you can multiply both sides of the inequality right here by a positive term. So what? You multiply 3y to x squared, I got 3y x squared over x squared plus y squared, going to be less than or equal to epsilon. It's really less than epsilon times 1. Okay? And this is exactly what you need. You try from x squared plus y squared squared less than delta. You prove that the function is less than epsilon. And by the definition, the limit of that thing is equal to 0. Okay? You get the limit equal to 0. As I say, you see, the proof to show that the limit exists is way, way harder than to disprove the limit does not exist of some function. And this is a very typical example as well. You start from delta, you try to find a connection between, start from epsilon, you try the connection between epsilon and delta, which is what we have right here, okay? And then you go backward of the whole procedure that you try to derive delta. And it should have the answer. Okay. And after having the limit, you check if the function is continuous at 0, 0. By what? Look at x equals 0, y equals 0 right here. So f of 0, 0 is what? See, this is f of xy, right? Equal to 3x squared y over x squared plus y squared. F of 0, 0 is what? 0 over 0 is undefined, so it does not exist. Means what? You have a limit. The function is not continuous at 0, 0. Okay? And if you can find somehow another problem, you plug in x0, y0, you got f of 0, 0 also equal to 0 as well, equal to the limit, which is 0. Then you say what? The function is continuous at 0, 0. Okay? And really, this is the end of 14.2. It's all about limit and continuity. And we have to use, again, the definition. And trust me, this is not the most powerful definition yet. Later on, if you guys learn more, we will talk about more general definitions. This only works for metric space that you can find the distance. Okay. Okay. Now let me get to the last part of the clip today. We're talking about 14.3. Partial derivative. 14.3. Partial derivative. First of all, let's talk about notation. Now you have the function f of xy, right? Say f x y z or x y z st, just 2 or 3 variables. Okay. And partial derivative means what? You take the derivative in terms of x only, or you take the derivative in terms of y only. Okay. So say take the derivative in terms of x. You have a couple ways to denote fx, or you can write as what? Say df over dx, I think. Df over dx. Oh, not this d. This d. Okay, you write this way. Df over dx. That's a curly d. Let me look for any other way of writing. If you have z right here, this is what I see. The book can write dz over dx. Okay. Or maybe d1f, I think. So in physics, usually they use it a lot. Let me check. Yeah. Or dxf. Those I don't use a lot. Usually I use write fx right here. Or df or dx. Those are the most two common notation that we use a lot in mathematics. Those. This one is as well. It's very used often. And those two, I think we use in physics more. Okay, so let me give you an example. I think it will work. Say fxy equal to 3x squared plus 4x y squared minus 2y cubed. Okay, so if you want to take the derivative with respect to x, you think of every other thing as constants. Okay, so now y is constant. Of course, 3, 4, negative 2 are constant. So what? fx, x variable, right? So in count 1, the derivative of this is 6x. What about this? Y is a constant, so 4y squared. Now, y is a constant. What happens when you take the derivative constant? 0. So this would be the answer. Similarly, if I want to calculate dy or fy right here, what happened? Now, x is a constant because the derivative with respect to y. X is a constant, so the derivative of this is 0. X is a constant, right? The derivative of y squared is 2y. So the derivative of this is going to be 8xy. Because the derivative of y squared is 2y times 8x. So 4x is 8xy. And then it's y cubed with negative 2. The derivative is going to be negative 6y squared. Now, what if you want to do the derivative one more time? Then we develop, I'm going to use the first notation right here. What if I want to do fxx? This is fx, right? We'll do fxx means what? I'll take the derivative of this one more time with respect to x. And this is equal to 6, and the derivative of this with respect to x is 0. What if I want to do this? fyy. 8xy derivative with respect to y is going to be 8x. Negative 6y squared derivative is negative 12y. Good? Okay, how about this? What if I want to do fxy? See, this is my fx, right? fxy, now I have to take the derivative of this one with respect to y. See what happened? Now x is a constant, the derivative is 0. 4y squared, derivative is 8y, because I'm thinking of y as a variable. X is a constant. Okay? Similarly, if I got fy right here, what if I want to do fyx? So fyx means what? You take the first derivative with respect to y, and then the second derivative with respect to x. If I have this one is fy, I take the derivative of x. What happened in here? 8x, I'm sorry, 8y, I mean, well, I have to think of the variables. X is the variable, right? So 8, derivative of x is 1, so 8y. X variable, so this is a constant, derivative is 0. Okay, so what I'm trying to show you in here, look at fxy is 8y. Fyx is also 8y. Okay? It's not a coincidence, guys. This actually have a theorem for that called the Lego theorem. Okay. I think that's guy's French, so his name should be pronounced as Lego theorem. Say what? If a function is continuous at the point, if fxy is continuous at the point a comma b, then fxy at the point ab will be the same as fyx at the point ab. And the example I'm giving you right here, the function is continuous at every single point ab that you can think of, because it's like a multivariable polynomial function. So you can take the derivative of any order, fxy or fyx, gonna be the same. Okay, that was a theorem. And of course, so you like second degree derivative right here, you can do what? X, or 3 or 4 times, it's okay, it'll be the same. Okay, let me see if I missed anything. The book didn't mention, but it just come up in my mind right now, and I want to recall you. There's a lot of rules that you guys learned in Calc 1 that will be used in here, and I just write it down for you, like, you know, for you to recall, to look back, if just in case you guys forget. You may need to know product rule. Look it up, okay? Quotient rule, chain rule. Those are the 3 things that for sure is going to come back in here when you guys take the derivative. So I think we still have time, so let me give you one more example that we may have to use one of the rules. Okay. fxy equal to x comma y equal to, how about sine of xy squared? Okay. Okay. So what is fx? Oop, I should not write this way. Fx. Okay. We're getting lazy. Just write fx formally. People should write it this way. X, sy. That indicates what? We are taking the derivative, partial derivative, with respect to the x. Okay? So the derivative of sine is going to be cosine of x, y squared. And now you have to use the chain rules. Okay? And we have to take the derivative of the thing inside respect to x, which is y squared. Okay? What if I want to calculate fy? Fy, right? The derivative of sine is cosine of x, y squared, and now inside is a mess, so we have to use the chain rule, take the derivative of the thing inside the parenthesis with respect to y, so you time what? 2xy, because the derivative of y squared is 2y times x is 2xy. Okay? What about fxy? Okay? Fx right here. I have to do what? XY. What? Now what? This is cosine of xy squared times y squared, and I have to take the derivative of this in the whole thing in terms of y. You see that we have to use the product rule and the chain rule because we have a product of two functions, right? So fxy. Right? Because the product rule is what? U times v derivative is u prime v plus v prime u, right? That was the idea. So I'll think of the whole thing right here is my u. This is like my v. The derivative of cosine is negative sine of x y squared. Now I have to use the chain rule because I have a mess in here. The respective y's I have to multiply by 2xy. This is u prime times v times y squared. This is my u prime, and this is my v. And then plus v prime times u. V is y squared, so v prime is 2y times u, which is cosine of x y squared. Okay? And you guys can simplify this a little. This is what 2xy cubed, but that's easy, so I'll let you do it. Let's try the other one. Fyx. Now I got fy right here. I'll take the derivative in terms of x. Okay? Again, I have to do the chain rules and the product rule. So I have what the derivative of cosine is negative sine of x y squared. Now I have to use the chain rule. Apply the derivative for the thing inside the parenthesis. Respect to x, I have to times y squared. Right? The derivative of x y squared in terms of x is just y squared. And this is my u prime times the v is times 2xy. And then plus the derivative of the second part times the first. The derivative of 2xy in terms of x is 2y and times cosine of xy squared. And you see that fxy really equal to fyx after simplifying. Okay? Just try to convince you that the theorem, the Clairaut theorem, actually works for a continuous function. Okay? Be careful. The power rule, the chain rules. The power rule is this: x to the n is the symbol, so you guys know. You go to n times x to the n minus 1. The power rule, the product rule, the quotient rule, the chain rules that you learn in Calc 1 for sure will be used in Calc 3 in a higher level. So if somehow you kind of forget or get rusty on those, please open the books again, Calc 1, same books we have. Okay? And look over it, but I bet many of you guys still have it because it stick with you when you learn calculus. Okay, I'm going to stop the video clip right here. If you have any question, please don't hesitate to ask, okay? The more you ask, the better for you to learn, and the more chance for me to have to help you. Thank you so much for watching, guys. Have a great day.